Hi, and welcome to the Food Sense Generation 4 weekly webinar. So we like to do this weekly webinar where we're really answering questions that have come in during the week. So today is the 13th of October 2024. I'm operating out of a hotel room, so it's a little bit of a different setup. But that said, let me go forward. Don't forget that everyone gets personal online training. So if you are a Food Sense Generation 4 user, you will get personal online training. We've done a couple of sessions just in the last week, we give slides, we give demos, we watch you, so they're really quite interactive. We do weekly webinars. So this week, actually, I'm more planning and thinking about, somebody's coming in with some very interesting questions about actually looking at the heterogeneity of capsaicin in a chili pepper. Most of the capsaicin in chili pepper is never in the seeds, but I'm sure most people know that that's just a myth. It's actually in the placenta, and I will be talking about that today in particular. We do monthly webinars. There will be a monthly webinar on the 24th of October. There's a link to it and a bit of a promotion for it in this slide deck, so I won't jump into that now. This week I've got questions. Do you need to do an annual calibration of the Food Sense Generation 4? And the quick answer is you do not need to do an annual calibration of the Food Sense Generation 4. Now let me give you a quick example of a technology. Now at Zimmer Peacock, we are ISO 13485 certified for the contract development and contract manufacture of electrochemical biosensors. Here's an electrochemical biosensor. This is actually for the measurement of glucose. So let me do another demonstration for you now. Or not another demonstration, let me continue the demonstration. Let me just get a sample. There we are, got the sample. Let me put the sample on the sensor. That'll take about 5 seconds. So that's a nice thing about by the way, the science behind a glucose strip and the chili sensor is actually exactly the same. So I've got a result now in 5 seconds of 97 milligrams per deciliter in my blood. All very well. Now, the reason I bring that up is because the question that's being asked is there any annual calibration required? And the answer is no. And I did that demonstration. In fact, I'm going to do another demonstration now as well while I'm at it. And the reason being is we are ISO 13485 certified at Zimmer Peacock, which means that we're very familiar with making point-of-care diagnostics for patients, clinicians, people in the medical industry. That means that we understand that in that industry, they stopped doing calibration in the field with patients about 20 years ago. They went calibration free. Let me just put a quick sample. Let me first of all just set up the app. I'll call this, I'm working upside down at the moment, so excuse me while I just flick it around slightly so I can see what I'm doing. Yep, tab 4. I've just given it a quick name. I'll go back, I'll put a sample onto this, which I will now do. I am still answering this question about calibration, by the way, because I'm just showing you how similar what I am doing is to actually a medical product. And off it goes. This is a really sweet technology. I mean, it's taken us, this is generation 4. It's, generation 4 means, you can appreciate we've been through our generation 0 effectively, our generation 1, our generation 2, our generation 3, and now we're on generation 4. And it has a lot of similarity to actually a glucose meter. So it does not require calibration. In fact, what I'll do now is I'm just going to quickly flick my camera to here, and I will go here. So every time we do a test, the results actually get sent up to the cloud. So the results just come through. So let me just change cameras for a second. That's correct. So I've got a result here, and Scoville heat units, and I've also got a result in my cloud as well. So I'll just change to here. I'll just go to here. I'll just do a quick refresh here. So this is also part of the kind of answering that question, do I need to calibrate? And the answer is no, because we are ISO 13485. We come from the medical diagnostics industry. In the medical diagnostics industry, we do not ask nurses and doctors and patients to calibrate technology. So we're bringing that mentality across to the food industry. The reason you can actually make sure that the instrument is working okay is because you will get a result on your phone. You do not need to be an electrochemist, and in fact, this is not the right webinar for teaching you electrochemistry, but in fact, if you are a customer of ours, you will get a result there and then on the phone. But the result is also saved to the cloud. So if you are the quality manager in a company, you can come in, you can see the Scoville heat units of that sample. You can also see the operator. So every operator can put their operator ID in there. You can see the time and date. You've got a lot of traceability as the quality manager. But this is the killer. You also get the raw signal as well. So you know if this instrument's working okay. Look at that. You can see that. That's peak 1, peak 2, and peak 3 of capsaicin. I'm really sorry. It's there. This is the bit. See, when people use, let's say, HPLC to do the analysis and they get it done by the lab, they never get the transparency and traceability that we are demonstrating here. You can see exactly where we're getting the signal from. And we've turned the signal through calibration into a Scoville heat unit. So you, every time you do a test, will always have confidence that the system is running correctly because you can actually see, the workings of it. And if you're not interested in the workings of it, don't matter. Look, you can see it. Oops, daisy. You can see it here. I've got the result on my phone, but I've also got the results saved up in the cloud as well. So the quick answer to your question is no, you do not need to do annual calibration. The long answer is why? Because in fact, I started making glucose strips after my PhD in 2000. And that was always my expectation that people would not have to calibrate in the field. And you can see that there's not only not calibration in the field, but there's also a real transparency in the way the system works because you can go in there and see the real data yourself. There is no AOAC, just out of interest, or certification example. So for example, the first HPLC testing was actually done in something like the 90s. And it's only 10 to 15 years later that actually AOAC sort of official methodology came out. I've got another company that I work on occasions with, and they've just got their food product AOAC sort of certified, and that's taken them 10 years. It takes a long time to get AOAC approval. In the meantime, the other company I'm referring to is actually doing really well, like we are as well. So it can take a while for the people like the AOAC to essentially approve something that's already out there using benefit. I just want to say actually a bit of a lesson from the world of diabetes. You see this glucose strip? This is used probably millions of times a day in hospitals. Do you know it wasn't originally or never approved for hospital use. It was doctors and nurses finding out that it actually added real value to their patients and their days who started using it. So it was actually used what we call off certification. So sometimes you do not need necessarily approval to actually add value to your, in this particular case, it was obviously the care of patients, but in this particular case, we're talking about rapid testing for the capsaicin in products. We do answer questions. We do weekly webinars, so there's good support there. Somebody's asking about how to homogenize samples, and the answer is blend, blend, blend. We'll talk about this in a bit more in detail in a minute. I think you can actually, if this particular customer or potential customer is interested in dissecting chili peppers and actually testing the capsaicin or the Scoville heat unit for components, let's say the placenta, and I think, yeah, great idea actually, and I'm actually going to try it, and the answer is yes, this is a great technology for that. You do not need to make samples like 0.1 grams in 0.9 mils. You can actually do 0.01 grams in I should have put I should rather, yeah, you could actually go down to that, but that is really low actually. I should have said something like 0.1 grams in 0.9 mils. So you do not have, you can change the volumes or the masses used accordingly if you want to save buffer. Just looking at that, that's a little bit too hard to do. That's 10 milligrams in 90 microliters. The 90 microliters is actually not that hard. 10 milligrams is a little bit harder to deal with. I will teach people how to do dilution. Just out of interest, actually, I might just change here. This is not, in food science generation 4, when we're running a test, we do actually ask the question, what's the dilution you used? If it's something mild, it's 1 in 10. If it's something a little more moderate, it's 1 in 100. If it's a little bit hotter, it's 1 in 1,000. If it's much hotter, it's 1 in 10,000. For example, if you got me a Carolina Reaper and you pulled out the placenta and we just measured on the placenta, that really could be a 1 in 1,000, 1 in 10,000 dilution requirement, because there's so much capsaicin in it. By the way, you see this app is smart. If you've not diluted enough, it will tell you that it's too concentrated and you need to dilute more as well. But as it is, you've only got four options anyway. I often start with 1 in 10, go to 1 in 100. But if it's a chili powder, I know it's going to be 1 in 100 or 1 in 1,000. If it's a consumer grade chili sauce, it'll probably just be 1 in 10. If it's an artisan sauce, something that somebody's put I make the world's hottest chili sauce, it'll end up being 1 in 100, 1 in 1,000. So you can sort of, and it is based on science. It's basically, capsaicin is an organic molecule. It only has a limited solubility. So if we want to extract it efficiently and dissolve it, we have to change the amount of solvent or buffer in order to extract it and dilute it. I will suggest some homogenizers to this person, and I'll start doing that today. Just FYI, this is a weekly webinar where we try to quickly and efficiently answer questions that are coming during the week. If you're interested in a much more deeper dive on this technology, then come to our monthly webinar. The next one's in 12 days, 24th of October. If you've missed it and you're watching this later on, don't worry. Click this link and it will take you to the next. I'll put this link underneath the video, and it will take you to the next one in the series. Question number 2, how to prepare homogeneous samples. Can we actually test individually things like pericarp, the placenta, and seeds? The answer is yes, and I think it's a good question, and something I'll probably do a bit of a dissection and a webinar next week. You can use considerably less sample. You do not have to be doing 0.1 grams in, or so even 1 gram in 9.9 mils of buffer. You do not need to be doing sample sizes of that type. Sorry about the typo there. Yeah, that's fine. You'll always need to be doing some sort of extraction and dilution. I will suggest some homogenizers. It is actually quite tougher to test chilies. I think chilies might be one of the toughest things to test because they're so heterogeneous, where things like chili sauces like Tabasco, which are extremely homogeneous, are super easy to test. So when we're trying to test very heterogeneous samples, we basically blend and mortar and pestle as much as possible, because we actually want to get as much efficient extraction of the capsaicin as possible. And so the more we dice it up in from big chunks to small chunks, then the greater the surface area, the more efficient the extraction is. I've actually ordered in a couple of a mini blender and also a mortar and pestle, because I've got a suspicion that people don't need large samples when necessarily homogenizing for test on the Food Science Generation 4. So I've bought in a couple of consumer grade, the mortar and pestle and the blender. I'm going to start trying them out and making videos about that. I think this person's asking a really interesting question, because the capsaicin is not evenly distributed throughout the pepper. And I think it's actually quite it's definitely an interesting question, as you know, because there is data about where the capsaicin is maintained, but it's not data that we certainly haven't gathered it in a long time, and I think we haven't made videos about it, so it is something that I'm very interested in. I'm just looking at the spelling of dissecting there. Dissecting, I'm not sure that that's spelt right. But that said, it is something that we'll be doing on this channel as in support of Food Science Generation 4, things like extraction of the placenta and actually getting a sample of it, diluting it in the buffer and testing it for capsaicin. We may have to end up putting something like 1 milligram in quite a lot of buffer, because it might actually be full of capsaicin. And I'll have to talk about sample size there, because if we test 1 placenta out of 1 chili, how representative is that of, you know, a ton of chili peppers? Probably not very representative. Anyway, there's more to come on this extraction and testing of capsaicin from things like the placenta, and I'll be doing videos about that. So if you've got any questions or got suggestions, please don't hesitate to reach out to us at ZP on the Food Science Generation 4. Okay, thanks very much.